Hello, my dear students. Good morning. So today we will solve one numerical on again the second law of thermodynamics. Some students they have requested to solve this numerical. This is from model question paper, thermodynamics model question paper. Okay, question number is 10B. Okay, anyway, I have taken the question number here and as well as statement of the question. So this numerical is related to refrigeration. Okay, or you can use the concepts of second law of thermodynamics also. Second law of thermodynamics, that is refrigeration, heat pump, etc. Okay, we read the statement, and some students also they have given in the comment section that you solve this numerical. Okay, so we were asked, we were requested to solve. Okay, please listen carefully. All of you read the statement, what he has given in the statement. First, question number, a reversed Carnot cycle. So keep in mind, it is a reversed Carnot cycle. Already we know that some air standard cycles, petrol engine, diesel engine, Brayton cycle, etc. works on Carnot cycle. That is direct engine. But here it is a reversed Carnot cycle, means it is indirect engine, indirect or reversed engine. And this Carnot engine is used for heating purposes and as well as cooling purpose. Okay, that will discuss what is the type of heating and cooling here in the solution. The work supplied is 10 kilowatt. As I told you, it is a reverse Carnot engine. The reverse Carnot cycle absorbs work. If it is direct engine, it produces work. It's like petrol engine, diesel engine, vapor power cycle, etc. The COP is 3.5. For cooling purpose, he has given. Okay, there are two processes are there. One is cooling and heating, but COP of this engine for cooling, he has given 3.5. It has asked determine refrigerating effect. Refrigerating effect, we'll call it as RE. Okay, or what is mean by refrigerating effect? Refrigerating effect is the amount of heat absorbed from the system or from the space where you need to cool. Okay, and as well as second unknown, what he has a COP of heating. COP of cooling he has given, and he has asked for heating, and as well as ratio of low temperature to high temperature. Ratio he has asked some percentage. So I will write the solution here. Let me write the given data also. Okay, first write the given data solution. First, assume it is a reversed Carnot cycle. The reversed Carnot cycle means it is indirect heat engine. Okay, there are two types of engines, right? Direct heat engine and indirect heat engine. So it is indirect heat engine. So this is used for heating and cooling as well. So what I do is, let me take one simple block diagram. Okay, so this is one engine, that is a refrigerator. Okay, it absorbs heat from a device from low temperature reservoir, that is you take T1, and rejects heat to high temperature reservoir T2. Okay, here this absorbs Q1 amount of heat from the low temperature reservoir and rejects Q2 amount of heat to high temperature reservoir by absorbing some external work. So how much external work he has given in the statement? The work supplied to the engine is 10 kilowatt. So W value work is 10 kilowatt. Next, is there any data is given other than this? Yes, COP of this engine is 3.5. Why he has given COP? Because it is a reversed Carnot cycle. If it is a direct heat engine, efficiency will come into the picture. Okay, but here it is a reverse, so COP is equal to 3.5. So what he has asked, determine, we will write here, determine the first unknown refrigerating effect. Refrigerating effect, as I told you before bit of time, refrigerating effect is amount of heat absorbed from low temperature space, low temperature reservoir. So Q1 we will call it as refrigerating effect. In short, Q1 is also called as refrigerating effect. If you know the enthalpy during the cycle, you can calculate refrigerating using M into H1 minus H4. But here we do not know enthalpy and what type of refrigerant he has given. So we cannot apply this equation until unless we know the type of refrigerant, temperature, etc. Understood? With the previous video lectures, we have solved how to refer the thermodynamic data handbook. So the values is based on type of refrigerant and the given condition, whether pressure is given, temperature is given. Here, there is no such data, so I cannot apply this kind of equations. So simple normal equation you have to apply. Second, what he has asked is COP, assume it is for as a heating. Cooling he has given, assume it is used for heating, then what will be the COP? Then third one is what he has asked, ratio of low temperature to high temperature. So here I have assumed, I have taken it as T1 is low temperature. So ratio of T1 divided by T2 is how much? It is very simple numerical. Okay. So let me first write refrigerating effect formula. Okay. So what is the basic formula for COP of heat pump or COP of refrigerator? Okay, there are two formulas. You remember this. COP of refrigerator is Q1 divided by W. Okay, Q1 divided by W when you are using refrigerator means Q1 is refrigerating effect divided by W. And whenever you consider refrigerating effect, assume this is cooling condition. Cooling condition. Okay, when you are taken here high temperature heat reservoir, for example, if you are taken Q2, Q2 is related to high temperature reservoir T2. In that case, it will become heating reservoir. Okay, because why I'm saying it is cooling condition is this Q1 is related to low temperature. So it is cooling effect is taking place. It is absorbing heat from low temperature reservoir. Q2 is high temperature related to high temperature reservoir. So it is heating effect. Okay. So for that reason, COP of refrigerator is Q1 by W. Same formula you can write Q2 by W, no issues, but that is for heating condition. That's it. So how much is a refrigerator? COP is given 3.5. Why I have taken 3.5? Because it is a cooling condition. The given statement he has given COP as 3.5. Let me show you in the statement here 3.5. COP is 3.5. So that is I have written here COP is equal to Q1 I do not know, write as it is, divided by W, that is work supplied to the pump. He has given 10 kilowatt in the statement, so substitute 10. So Q1 is equal to 3.5 into 10. Q1 you can say it has a refrigerating effect also, that is 35 kilowatt. Okay, so sorry, 35 kilowatt. This is the first refrigerating effect. And dear students, sometimes in the question paper, he may ask you to calculate in terms of tons of refrigeration. It is in terms of kilowatt. It is not in terms of ton. Okay, do you remember 1 ton of refrigeration is equal to 3.5 kilowatt or 210 kilojoule per minute. Okay, you convert into joule per second, just divided by 60, you will get this kind of 3.5 kilowatt. So 1 ton of refrigeration is 3.5 kilowatt. This is unit of refrigeration, keep in mind. Unit of refrigeration. Always refrigerating capacity will be measured in ton of refrigeration. Okay, we got 3.35 kilowatt. Here is 3.5. So for 3.5 kilowatt is equal to 1 ton of refrigeration. So 35 kilowatt is equal to how much? So 35 divided by 3.5, that will be the answer for refrigerating effect Q1 in terms of ton of refrigeration torr. Okay, tons of refrigeration will call torr. Okay, whatever the values is there, you write here. That is in terms of tons of refrigeration. But here in the question paper, what I have taken in the statement, it is he has not asked in any condition, just he has asked refrigerating effect. So either you can put in kilowatt or you can put in tons of refrigeration, no issues. The next point, second point is COP of heating. So what is the main condition it will change? COP of heating. Instead of Q1, I will use on Q2 now. So that is for heat pump. Okay. You remember some of the numericals we have solved in the previous classes. Okay, let me write here. COP of heat pump or heating is equal to Q2 divided by W. So this is unknown. We do not know. And we don't know Q2 also. But W we know, that is 10 kilowatt. Work supplied to the refrigerator or reverse heat engine is 10 kilowatt. So how to calculate Q2? Okay, let me draw the same diagram what we have taken in the first page. Q2, this is related to T2, this is Q1 related to T1. And dear students, you can change anytime. Okay, it doesn't mean that always Q2 is at the bottom side, no issues. You can take Q2 here and Q2 is related to T2, that we can assume it as low temperature reservoir. Okay. You apply one simple hint. Input is equal to outputs. Inputs is equal to output. For this cycle, which are the two inputs energy? W is one input to the refrigerator and as well as Q is also one input. So W work plus Q1 is equal to output. Okay. For this cycle, just input energy is equal to output energy. So I need Q2. So in place of Q2, I can write W plus Q1. So same thing I will write W plus Q1 divided by W. So you can simplify this equation or else directly you can substitute. Okay. Q1 already we have calculated, it is 35 kilowatt already in the previous page. You have calculated here, it is 35. That you substitute here. COP of refrigerator, that is heat pump, it is for heating. We are calculating for COP of heating. W is 10, Q1 is 35, both are in kilowatt. So W is 30. So how much will be 10 plus 35, 45, 45 divided by 10 is 4.5. COP of heating is 4.5. That's it. Very simple. Okay. There is one more standard equation is there. You can use that also to calculate COP of heat pump. What is that standard equation? I think you remembered. COP of heat pump is equal to COP of refrigerator plus 1. Okay. COP of refrigerator already has given as 3.5 plus 1. You can calculate. Same answer we get. Okay. But you need to choose the method. Depends upon the marks. If they ask for only 1 marks, you can use this equation. If they ask for 2 or for 3 marks, you can use such type of steps. It is left to you. Answer is same. Next, what is the third condition he has asked in the question? Is ratio of lowest temperature to the highest temperature. So lowest temperature here is T1. Okay. And highest temperature is T2. Let me take different color. Yes, lowest temperature is T1, highest temperature is T2. So how to calculate this ratio? That is a very easy. So COP of refrigerator is equal to Q1 divided by W. This is a condition I will take. This is for cooling I will take, okay? Because condition he has given for cooling, COP is 3.5. So we will not get any error. So exact answers we will get. So COP is 3.5. Q1 is related to which temperature? Q1 is related to T1 temperature. It is related to low temperature device. Okay. For example, I will draw the same diagram what you have taken in the previous pages. So T1 is related to Q1, Q2 is related to high temperature reservoir T2, and we are supplying some mechanical work W. So for that reason, I have taken Q1 as T1. So what is W? W is not related to temperature sources, but we can convert W in terms of temperature. How will convert? That is same, input is equal to output. Here W is one input, Q1 is one input, is equal to Q2. Q1 is input to the refrigerator, W is also input to the refrigerator. Sum of two inputs is equal to one output. Okay, so I need W in terms of Q1 and Q2. So Q2 minus Q1, I will take it as W, Q2 minus Q1. So now you can substitute the value of Q2 and Q1 directly, or else we can convert into temperature. But here it is better to convert into temperature. Okay, because he has asked temperature ratio, right? So Q2 is related to which temperature? Q2 is related to T2 temperature. T2, Q1 is related to T1 temperature. So simplify this equation and you can convert a ratio. So 3.5 T2, just to cross multiplication, 3.5 T2 minus 3.5 T1 is equal to T1. So 3.5 T2 is equal to, if you take on the right hand side, it is 3.5 T1 plus T1, that will be 4.5 T1. Okay, so 3.5 T2 on the left hand side, and he has asked ratio of low temperature to high temperature or high temperature to low temperature. That is what we needed here. Low temperature to high temperature, T1 by T2. It depends. He can ask for high temperature to low temperature also, no issues. So here he has asked for low temperature is T1 and high temperature is T2. So I will take it as T1 by T2. T1 by T2 is equal to 3.5 divided by 4.5. So this is the ratio. Whatever the answers you write, that will be the ratio. You will get maybe 0.77 something, or you can put it 35 by 45, whatever the values. So 7 by 9. 5 7 is 35, 5 9 is 45. So 7 by 9 is a ratio of low temperature to high temperature. So this is a simple solution for this question paper. This is a model question paper. It will be asked for 10 marks. Okay. If you have any doubts, you can mention in the comment section or you can ask me doubts. Okay. Thank you. So in the next tomorrow class or in the evening, you'll come with a new problem. Bye-bye. Take care.